Lesson 1-1, Variables and Expressions, and in this lesson you will learn to translate verbal expressions into mathematical expressions and vice versa. Let's consider this example in health. Many people enjoy going to the beach in the summer. Many sunbathers use sunscreen lotions to protect themselves from the sun. Sun protection factor, or SPF scale, gives you numbers that represent the length of time you can stay in the sun without burning if you have lotion on. Again, this is what SPF means because this will be very useful when you go to the beach. Okay? So just saying, this is the length of time you can stay in the sun without burning if you have lotion on. Okay? How does that go? Let's say you can stay in the sun with no sunscreen for 10 minutes. Let's say you go out in the sun and with no sunscreen at all, after 10 minutes you start getting sunburned. Okay? So that is your limit under the sun without lotion. If you put SPF 5 lotion, you can stay in the sun for 10 times 5 or 50 minutes or a little less than an hour. Okay? And this table will show us more, okay, so SPF numbers. So if you can stay under the sun without burning for 10 minutes and you put on a lotion with SPF 5, you can stay under the sun for 50 minutes. Okay, again, if you can stay under the sun without burning for 10 minutes and you put on a lotion that's SPF 15, you can stay under the sun for 150 minutes, so that's roughly 2 hours and 30 minutes. Okay, if you have delicate skin and you can only stay under the sun without burning for 5 minutes and you put a lower SPF, you can only stay under the sun for 20 minutes. And if you can stay under the sun without lotion for 15 minutes and you put SPF 8, you get 120 minutes of not burning, or 2 hours. Okay, we can represent all these numbers, minutes in the sun without burning, as M, and we can represent the SPF number as S. And if we represent the minutes in the sun without burning as M and the SPF number as S, the minutes in the sun without burning would be M times S. Okay, so if you notice in this case, 10 times 5 and 10 times 15 are what we call numerical expressions. Okay, numerical expressions, if you recall, are simply a combination of numbers with at least one operation. That's a numerical expression. Let's define some more terms, and we've discussed a few already. The letters M and S are called variables, and M times S is what we call an algebraic expression. In algebra, variables are symbols that are used to represent unspecified numbers. Any letter may be used as a variable. We selected M because it is the first letter of the word minutes, and S because it is the first letter of the word of SPF. Okay, the most commonly used variable in math in algebra is the variable x. Okay, and we avoid using the variable I or L, lowercase l, and the variable O because they might be confused with the number 1 and the number 0. So we try not to use I and O, but in some cases we still do. Okay, so let's define what an algebraic expression is. An algebraic expression consists of one or more numbers and variables along with one or more arithmetic operations. And if you recall, there are 4 arithmetic operations: multiplication, division, subtraction, and addition. Okay, so again, this is the definition of an algebraic expression, and you need to write this down in your notebook. Examples of algebraic expressions: x minus 2, a over b plus 3, t times 2s, 7mn divided by 3k. Those are all algebraic expressions. Okay, at least one or more arithmetic operations, and if you look closely at these examples, this has one operation. Okay, right there, a subtraction sign is one operation. Okay, there's also your a over b plus 3 will involve 2 operations. You have division here and you have addition. This will also involve 2 operations, multiplication here and multiplication there. 7mm involves multiplication and division multiplication. So those are good examples of algebraic expressions. Okay. Now let's discuss how we use symbols in algebra for multiplication. So in algebraic expression, a raised dot or parentheses are often used to indicate multiplication. Here are ways to represent the product of x and y. xy is multiplication, x times y, x parentheses y, parentheses x times parentheses y, parentheses x y, and x times y. These are all ways to represent the product of x and y. Okay? And in each of the multiplication expressions, the quantities being multiplied are called factors, and the result is a product. So when you multiply two numbers together, okay, the numbers that are being multiplied are called factors, okay, and the result will always be product. Okay. In algebra, however, if you notice this, these are the ones that we use mostly when you are talking about multiplication of variables. Okay, we try to avoid the raised dot in this particular representation simply because the raised dot will sometimes be confused with a decimal, and the multiplication sign can be confused with the variable x. Okay, so we use these, okay, in algebra more often than not. Okay, moving on. It is often necessary to translate verbal expressions into algebraic expressions. For example, if you have the verbal expression 7 less than the product of 3 and a number x, okay, when you say 7 less, okay, 7 less indicates minus 7 right there, okay. 7 less than the product of 3 and a number x. This will mean the product of a number 3 and the product and the number x. Okay, the product of 7 and s divided by the product of 8 and y. So the product of 7 and s divided by the product of 8 and y. Okay, 4 years younger than Sarah, if s represents Sarah's age. So 4 years younger, okay, simply means minus 4. You subtract 4 from the age, okay, and s represents Sarah's age, so s minus 4. And finally, half as big as last night's crowd. When you say half as big, okay, you say 1/2 of last night's crowd, which is c. Okay, so if you do 1/2 times c, right there, you end up with 1/2 times c over 1, or c over 2. So half as big as last night's crowd is c over 2, because you're dividing last night's crowd by 2, and the fraction bar indicates division. Okay, let's take a look at example number 1. Write an algebraic expression for each verbal expression. 3 times the number x subtracted from 24. Okay, so 3 times the number x subtracted from 24. Okay, that's your 3 times the number x, and then you are so going to subtract it from 24. Next one, 5 greater than half of a number t. 5 greater means addition, so it's t over 2 plus 5, or 1/2 t plus 5. Both will work, because as you recall, and which we will also discuss or review later on, t over 2 plus 5 and 1/2 t plus 5 is the same as what we did with half as big as last night's crowd. Okay, and there's also one more thing. This can also mean, okay, t over 2, 5 plus t over 2. And this is due to the commutative Okay, property of addition. We are also going to review this a little bit later on. Okay, but we did this last year, so if you remember that, good. Okay, you are already one step ahead of the game. Good example 2, another important skill in translating algebraic expressions is translating algebraic expressions into verbal expression. Write a verbal expression for each algebraic expression. You have the quantity 3 plus b divided by y. Okay, so you can say that this is the sum of 3 and b divided by y. And I'd like to call your attention on the word sum. The word sum basically is a clue that you are going to create parentheses. Okay, so basically what it's saying is that you're adding 3 plus b first before you're dividing it by y. So you get the sum of 3 and b and then divided by y. In the next example, letter B, 5y plus 10x is the product of 5 and y plus the product of 10 and x. That's pretty simple. Okay. So in the next concept that we will learn, before we go to example 3, are exponents. An expression like x to the n power is called a power. Okay. The variable x is called the base and n is called the exponent. This whole thing is called your power. So this whole thing right here is your power. X to the n is the power, where x is the base, n is the exponent. The exponent indicates the number of times the base is used as a factor. Okay, again, a review. X squared means x times x. 12 to the 4th power means 12 times 12 times 12 times 12. Okay, and if you look at the table right below, it will give you more examples of powers. So you have you read 5 raised to the first power as 5 to the first power, and that simply means 5. Okay, and a lot of times we don't put the 1 anymore because it is given as 5. 5 raised to the second is 5 to the second power, or 5 squared. Again, as a review, why is it called 5 squared? Because 5 times 5 forms an area of a square. That's why it's called 5 squared. 5 raised to the third power is called 5 to the third power. 5 cubed. Why is it cubed? Okay, because if you recall, okay, 5 times 5 times 5 will give you the volume of a cube. Okay, 5 raised to the 4th power is 5 to the 4th power, and this is 3a to the 5th power, 3 times a to the 5th power, which means 3 times a times a times a times a, and x to the nth power, okay, is simply x used as a power n times. So you don't know how many times x is used as a power unless you identify what the value of n is, and that is also read as n x to the nth power. And let's take a look at example 3 and see how this works. Write the power that represents the number of the smallest squares in the large square. So in this example, there are 8 squares on each side. Obviously, the total number of squares would be 64, because 8 squared equals 8 times 8, or 64. Okay, and if you want to use a calculator, you can use the x squared key on the calculator to square the number. So you enter x, press the x squared key, it will give you the value of 64. Okay, the word that always comes up, okay, ever since 6th grade, is this: evaluate. So when you talk about the word evaluate, to evaluate an expression's means to find its value. Again, it also means two things: substitute, and secondly, simplify. Most often than not, when you find the value of an expression, you need to substitute, and then you need to simplify. So when you talk about 3 to the 4th power, okay, 3 to the 4th power, substitute the value of 3 to the 4th power or expand this. So this becomes 3 times 3 times 3 times 3, or simply 81. Okay? Again, you can use a calculator to do this. You can use now the y to the x key on the calculator to raise the number to a power. Simply click on 3, press 3, and press the y to the x key, and then 4 will give you 81. And that's how you use this in a calculator. Okay? And that's the end of the first lesson. Go on Google Forms, type a summary of what you've learned by responding to the objectives of the lesson, and type a question you may want to ask in class. Thank you.